Okay, hopefully they will join us. So let me get some equipment and we'll start. All right. Hey. Good. The hardest thing about this is getting it all set up nice and beautiful. Anybody out there? Say hello so I know who you are. You need some clamps and you need a couple of clamp holders, which look like this. So that's going to go like that. And like that. So the thing about these items, these are called burettes, these glass items. That's all the stuff we got to talk about. Okay, so get this guy hooked up. Okay, the trick is to have it hold it, but not so incredibly tight. Because if I do too tight, what happens with the glass? It breaks, and they're pretty expensive, so I'd like to keep them as long as we possibly can. That's unscrewed. Come on. There's that screwed in. This way. There we go. So, all right, that's getting irritating, but I wanted to show you how it works. So your setup's going to be like this, and that's not even. Oh, try and do that. And I got to have this probably a bit higher. So let's move this one up. So, we'll do it. Move up a little bit. Be like that. Okay. I see somebody there, but they're not saying who they are. Strange. Let's fill it. Okay, what you're going to do first is, other than, as you can tell, this takes a while to get ready. By the way, if we don't finish today, don't worry. We'll be able to put these on a cart and save our setups for next time too. So your hard work getting ready won't be a problem. That's not perfect, but I'll fix it later. Let's fill this. Okay. So the lab has more or less two parts. And the first part is we're going to do what's called standardizing one of our chemicals. What do you suppose standardize means here? What might that mean we got to do? Alex? In the past, we've had that as standard conditions, especially when we're talking about gases, but it has a different meaning for titration. So it's a different meaning than that. Anthony? No, we don't have to dilute it. No, that's the titration itself. Standardize is to find a standard. So we've got to find what its exact concentration is. So that's kind of like, okay, what is the base that we're using? It's NaOH. We've got to find its concentration, which I'm not giving you. And you'll see how to get that. Once you have the concentration, then part two is we're going to use the standardized base. So the concentration you find to find the concentration of an HCl solution. So in a sense, you got two unknowns. The first unknown, you've got to find the concentration of your base. Then the second is, once you got your base, you're going to figure out the concentration of an acid that I mixed up for you. So I mixed up both yesterday, so they should be at room temperature, and everything should be fine. We shouldn't have to worry about temperature today with all these fluids. Right. Okay. Now let's get some beakers. I advise you to write a lot of this in pencil. Especially on your beakers. So what we're going to do, anybody there? Nobody there. Where did I set that? I know I brought a pencil. Fiddly boo. It's the trouble when I got to carry everything around classroom. Well, I got to go get another one. So I got two beakers here. This one I'm going to write NaOH on, and everybody will be able to use this. I've also got NaOH written on this one here, and I'll probably put this under the back hood when I'm done, all right? But for now, let's go ahead and put some in here. The problem with the NaOH with the flask is it's just too big and bulky to fill this. So I'm going to get this other thing. I'm going to call it my waste beaker. You know what? This is really too tall. I want a shorter one, so it fits easier. Take that. And I'm going to write on here W for waste. And what you can do is the waste that you had today, and it won't be a lot of milliliters, but you can put it in a waste beaker I have by the back sink back here. I'll put a really big one. And you can just occasionally dump yours there if you need to. Okay, so I'm going to put that there because I don't know if this is open or not. And I got to kind of lift it under because I don't want to break off the tip. And now I'm going to pour some in. And I hope it's closed. If it's at a right angle like this, it should be closed. So we'll see if it is. And I'm going to pour some in from the top. And you can get a chair if you can't reach it so well. And is it going through? No, good. Okay, now, I want to pour a little in anyway, and I want to just rinse it and let it go through. Why do you suppose I want to do that? And Sophie? To clean it. So they should be clean already. The last teacher was probably me, but if it was someone else, usually we clean it and then we rinse it again with distilled water so there's nothing gooey on the inside or any chemicals or minerals left, and then we let them dry. So it should be clean anyway, but let's just make sure. So we're going to rinse through all of this. So I'm not going to fill it up completely. I just filled up a few milliliters. So I'm going to just let that drain out into my waste beaker. And say we're getting rid of any last contaminants that might be in our burette. Have any of you used a burette before? You have that in another class? Okay. And it's good that we're doing this. Okay. So I closed it, and now I'm going to fill it. And really, if I was you, I'd fill it up to the very top, but I'm not going to do that because I don't want to waste the solution. So you're going to fill it up. And the thing is, there's numbers here up till here, you really don't need to go above there. If you go above the numbers, then it's not very helpful anyway, and I got to drain down in here. On the other hand, there's no need to go to exactly the top. It doesn't matter, as long as you're somewhere up here when you fill it. Don't waste your time. Oh, I need exactly 0.00. No. If you start at 1.12 or whatever it happens to be, that's fine. Okay. The other thing that can happen is sometimes you get a bubble and you can see it either here in the tip or back here. And what you want to do to get rid of the bubble, because it's just empty space, right? It's air, is you want to kind of go like this and just sort of get that through until you get all the bubbles out. I don't think I have any now, but if you do, that's sort of how you get rid of the bubbles. Good. Let's talk about refilling as well here. So once you get down at the very bottom, the numbers stop. You don't want to go beyond there. Why not? What if I keep titrating down below this spot where there's numbers? What's the problem, Anthony? Yeah, I can't calculate anything. So what you do is you don't panic. You stop, you write your number down, and you will be able to subtract, right, the beginning number from the end. We'll talk about that in a moment. And then just write it down, no big deal, and then keep going. But first you got to refill it up to here again. Then write your new starting number, and then keep going until you actually get like a color change. I'll show you our indicator we're going to use in just a moment too. So don't panic, but don't go below here because then you got to throw the trial out because you have no idea how much you added if you go that far. Your first trial is the hardest because you don't really know how much to add. I know that. And I have something to help you, and it's this guy. It's an automatic stirrer. So I'm going to throw it in, and, well, that's my waste beaker. So I'd have another beaker. Well, let's pretend that's my other beaker. So here's my other beaker, and let's say I've got my acid in there, okay? We'll talk about this in a sec. Anyway, then you throw in this guy. It's a little magnet, and then you turn it on, and very nicely, it does what for you? It stirs it. It's an automatic stirrer, right? So you get a stirring experience today, and that way you don't have to fuss with it. You can just add this drop by drop to neutralize. In this case, I would have an acid I'm neutralizing with my base. Okay, so that's kind of fun. Okay, what else do I need to show you? Let's talk about the readings. For the readings, and of course, I've got this where I can't see it very well. I got to move it down a tiny bit. These things are super accurate burettes. So I'm going to give you the reading, although your eyes are going to be a lot better than mine. It's also kind of strange. The numbers are backwards from the way you might think. Be right with you, Anthony. So it's going to be where the low spot is, right? The meniscus. You probably read that in other things, test tubes and stuff before. And it's between 49, which is down here, and 48. And for me, it's 40. And this is where you really got to think about it. Okay, 48, 49, 50. So it's between 48 and 49. So it's 48.1234. And I'm going to say 48. 48.48. Let's say that's my starting milliliters. So these go to the hundredths place. You shouldn't round them to the tenths place. You want as much accuracy as you could get. So use all of the accuracy of the burette. If you go between the lines, you can guess the hundredths place. Super accurate. Before we finish this, Anthony. How do you want to get once it's neutral, you can just once each of your things are neutral, you can actually then pour it right down the sink, and you can rinse your flask a little bit with tap water, and then with distilled water, and then you just get it out on the table. Once you neutralize, it won't hurt you or the sinks or anything. Okay, so you'll be able to reuse it over and over. In fact, you can use the same flask over and over and over to titrate as well. Okay, good. Let's say I take just a tiny bit to neutralize my solution. So I turn my stirrer on, and my color hasn't changed. Whoop, now my color changed. Okay, let's pretend that. Now I'm going to read it again. So I'm at 49 point. Oh, that's 5, 4, 3, 2, 1. 49.08. So when you get to the lower end, that's the bigger number. So where I ended is my top number when I'm subtracting. It'll be fine once you do it the first time. So then you gotta do that. And 0.60, huh? So 0.60 milliliters used. Now that's not much. You may have, I don't know, 30 or 40 milliliters used, so you've been using a lot more for your trials. Okay, let's get down to the nitty-gritty of how we're going to do this. So, for part one, and by the way, I have nothing to hand out, so you're going to do your work on separate paper. Let's go ahead and start you off, actually. Okay, hold on. So, whatever paper you're going to use for this, you're going to start out, let's call this titration lab. And we got two objectives, don't we? To RB and okay. So, give me our two parts. So first off, we're going to our base, new word, Ellie, standardize. And the second, who else is following Penelope? Of the HCl. Okay, good. I don't always do this, but I'd like you to then list the equipment they use, so the materials, because you're using some new stuff. Ask me names if you need to know. So this would be like a stand, and these are clamps, and your burette, and some beakers, and your stirrers, and automatic stirrers. Anyway, ask me anything you need to about the materials you're using. Yeah, I'll tell you which one it is in a second, too. You can write the name of it. So I'll let you fill in all that. I think I don't want a procedure for this lab. And the reason I don't is I got to explain so much to you anyway. I don't need you to write this up. Let's go right to the data and calculations. Okay, so the indicator, well, you can put this on the materials too. Okay, the indicator is phenolphthalein. And if you don't want to spell it, just read the bottle and you'll see how to spell it on the bottle. Okay, so I'll put all this maybe back here. Alex, we got to stop here. And you should be off. So, how much indicator do we need? Folks who use indicators before. How much indicator do we need? Yeah, 1 or 2 drops is fine. Okay, a couple drops. Good. Phenolphthalein is the one that turns clear to pink. So it has a really exact change. That's why we use it. And it's a little on the basic side. And if you look at number 1, you'll see why we're picking this. Here's what I mean. Normally, if I had a strong acid and a strong base, that would change and reach the equivalence point at what pH? If I had a strong and a strong, it would be the pH. It would be at, what's here? 7. What if I got a strong base and a weak acid? It would be more like where Penelope. More than 7, exactly. So that's why we use the phenolphthalein. It changes around like, I don't know, 8 or 9 or something like that. I can use it for part 2 also, where I got a strong and a strong, because the curve is so steep that it doesn't really matter which indicator I use for part 2. But for part one, where we're standardizing our HCl solution, we're going to use, yeah, okay. Yeah, we're going to use phenol potato. For the whole lab, we're going to use that. So what you need is frankly, you need a weak acid. So here's the one we're going to use. I'll have it back by the scale in the back room. If you remember where the balance was we used. You don't need much of this. I'll put it in the materials. So it's potassium, hydrogen, sulfate. It doesn't really look like an acid, does it? But it is. What happens to the potassium? What does that do? That's a what? Spectator. Good. And so that's a spectator. So here's what you got in your beaker. HSO4 minus, and if I add OH minus from the NaOH, it's going to make H2O. So I'm going to neutralize this, aren't I, Lola? So it really is a weak base. Weak acid, okay? So that's the weak acid you're going to use in part one. Now, I'd like you to do 3 trials. I need you to write some things that will not be in your lab. Can you just, what I write now under notes, don't put it in your lab, but I just want to have it visually. Okay, so notes, not in lab. So you can either just not write this down or write it somewhere else, okay? So use 0.3 to 0.4 grams of KHSO4 per trial. 2, 3 trials. If one of your trials stinks, throw it out and do another one. You know what I mean? So get 3 decent trials. We're going to have time. Again, if we don't finish it today, we're going to finish it next Wednesday. So that's all okay. All right? Okay, do 3 trials. Show math to 5 NaOH and average to 3 trials. Kind of makes sense, right? And this is all more or less part one. The balance in the back room goes to the hundredths place. So, I mean, you write down whatever I got, 0.33 grams or 0.39, whatever it happens to be. Just try and get it somewhere in there somewhere, okay? If you over or undershoot it, it's not a big deal, but you can't really have too much because then I use too much base and we run out. Okay. I better show you that. So, just as a reminder, here's some weighing paper, right? Some weighing paper. That'll be by the scale in the back. So you're going to have a spatula. Remember, 0, you know this, right? Tear the scale, 0 the scale, put with the weighing paper on there, add just the right amount you need, come back, and then you're going to get ready to do your titration. Now, people do titrations in a flask. Generally, like a 100 milliliter flask. We got a bunch of them. So put your acid in here, and then I want you to add some distilled water. Doesn't matter how much distilled water I add. No, because there's no what in it. Here, there's no what in it. I can add any amount of distilled water because there's not what in there. Yeah, exactly. It's not any acid or base. Okay, so you're just doing it so you got something in there to see. You know what I mean? Okay, then you're going to add to that, of course, your 2 drops of phenolphthalein. If I forget to add those 2 drops, how long will I be titrating? From now till Christmas, okay, or longer, all right, forever, because you won't turn unless you put those 2 drops in. Don't forget. Okay, so let's say I'm ready to do my titration, and so I'm going to put it in here, and I'm going to put in there, of course, my little magnetic stirrer. Where's my pile of magnetic stirrers? I'll put it somewhere here. Here they are. I really don't like the ones in here. That one's not bad, but some are really small, some are really big. That's a pretty good size right there. So add that in there as well. And I'll get the stirrers out for the different groups as well. Yeah, then you just titrate. You use your base, right, to titrate your acid. Okay. Questions about part 1? That kind of makes sense. When you get to the math, call me over if you got problems, but I think you'll figure it out by this time, right, to figure out the concentration of the acid. And it's a 1-to-1 relationship, right? For every one of these, 1 OH minus will react, so it'll be all 1 to 1 to 1 to figure out the moles. Okay? That's okay.
Would you like us to set up a table for each trial?
Well, you should set up a table for your trials. That's what I would do. So you and your partner decide how you want it to look, but you'll need to have spots where you got, you know what I mean, the end and beginning like this, Sophie, so to speak. And again, if you screw up, you may want to do it in pencil because it's your first time setting something up like this. Okay? Anything else before we talk about part 2? Okay, part 2 is even simpler because now you've got the concentration of your base. And so more notes. HCl is your acid in part 2. Use 12 to 14 milliliters HCl for each trial. And again, do 3 trials. Show you math. Average trials to get concentration of HCl. That'll also be a 1-to-1 thing, right? NaOH plus HCl, I get 1 water, so that's pretty easy. What nice equation can I use for part 2? What nice equation would do that? Aiden? Yeah. So that's pretty slick. So that's a nice one to use for this. Again, Cheryl doesn't like it, but it's the easiest way, and it should be used, in my opinion. Good. Let's talk about where the chemicals will be. So what I better do, being a good scientist, is I better put the NaOH, and if this runs out, this beaker just pours some more in from the flask. It also says NaOH, and I got a second flask if we run out of the NaOH. I'll put that under back here to the fume hood. Sloppy me, I didn't put my goggles on, but I should. Now they're on, I'm going to leave them on during the whole time. So just leave your goggles on today. And no one's watching, so adios, muchachos. There's no point in me doing this. All right, I'll deal with that later. You guys are more important here. Questions on part 2. Part 2. Okay. After every trial, to answer again Anthony's question earlier, it's neutralized, so it's whether it's part 1 or part 2, it will not hurt the pipes or the environment. So you can pour it right down the sink, and then you can reuse the same flask. You don't need another one. Just rinse it with maybe tap water, add some distilled water, swirl it once, out you go. Okay? If you run out of distilled, let me know and I'll fill up your bottle for you in the back room. Okay? Got plenty of distilled water. Right. So do your titration with the little flask. That's it. Questions from you? If you want to work with somebody from home, call them up. That's fine. Maybe one per group. If you don't, that's up to you. I feel like they should have signed in, but they didn't, so that's their problem. Ah, is it the other seniors or who is it, Alex? But you guys aren't taking it.
No.
What's that? Yeah, okay. Mr. Lang. You're not into Mr. Lang.
No, it's just AP Chem.
Oh, okay. AP Lang.
No, I'm not.
I'm just kidding. Okay, so here we go. Thank you for that. I wondered where they all were. So Louise is probably there too. Tell Louise I got her book graded and she can get it from me whenever. And I know she's not available. So I got 5, 6, 7, 8, 9, 10, 11. So we got some groups that will need food. Not here, 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 and here. Okay. So let's do mainly groups of 2, and I'll do one group of 3. Okay. So I think I got everybody. What's that?
Oh, you're making the group?
Yeah, I'm gonna make the groups. So here we go. So let's go. Anne Sophie and Feeny, Chelsea and Anthony, Aiden and Alicia, Lola and Penelope. And then a group of 3, I got Alex, Errol, and Ellie. Lots of vowels. That'll be my vowel group. Okay, so I'll start to give you all this stuff. Maybe I'll put it on the front desk here so you can get to it. And here's the wires for the stirrers. I'll bring those stirrers out. Okay. There's that. There's that. Okay. These guys. There's some smaller things, and here's some more. Works well. Okay, the acid, we'll put that by scale here. Yes, you can. Let's make sure it's tight enough so nothing comes apart. Okay, use two hands, and I think you can take that.
Thank you very much.
You're welcome.
You need to watch on.
There's a couple really big stands if you want some really big stands.
Oh, we know. Don't need to put the base on.
Okay, I've got your directs when you come on. Hand some to boots. Your direct boots to the back and let me know I'll get you moving.
Oh, I guess I did. Nope. We keep these. We keep these on in the break. All right.
Okay. Who needs a stir yet? What do you need at the table?